so we need accessibility to the part, and for this we need clever clamping solutions. But not just the clamping solution, we have to integrate this in our value chain. And here I can now ask Riccardo Bazzo from FCS System. I hope I pronounced your name right. Yeah. So he will give us an insight in FCS Systems and how they provide clamping solutions. So stage is yours.
Thank you, Mr. Kirbach. Hello to all the people that are following the presentation from the studio, and also to the people that are following the presentation from home. My name is Riccardo Bazzo. I'm currently working for FCS under the role of sales manager. It's an honor and pleasure being here to present FCS in these technology excellence days dedicated for the Die&Mold industry. It's an honor also being here as a DMQP partner, and today the name of the presentation is the clamping system designed and developed by mold makers. Before to start the presentation, let's have an overview about the outline. And first of all, we're going to talk about a company overview to introduce, to understand where we come from, where we are present in the market, and what are the core sectors. Then we are going to see what is our system about. And then we're going to see the benefits related with our system. And then we're going to actually see a case study together. Let's start. In order to understand our history, we need to do a step back in early 2000, where two of the biggest plastic injection mold makers were partners. And these two tool makers were into the mass production. And they started analyzing the costs related to producing the molds. And they found out basically that almost 50% of the cost was coming from machining and people production cost. And they started thinking, how are we able to minimize these biggest costs? In order to understand even further the necessities of mold makers, we need to understand what are their necessities. Because usually one mold is different from another, so they have always different parts to clamp, also always different geometries that are not always easy geometries. Usually these geometries needs to be reworked over time. After even the assembly, there could be the chance to do little systemation, so to remachine the workpiece. Then in this sector, usually all the workpieces are not done into one single machine, but they need to pass through different machines. And also they have all the thermal treatment to actually undertake. In order to solve all these issues, FCS was born in year 2003 from the spin-off of Hellman, which was one of the two partners that we have seen before. And the FCS system is a clamping solution provided, and usually our system are patented all around the world. Here I provided also an example to understand what we are speaking about, and we have done a partnership with DMG Mori to be present also here. Here is an overview about our presence in the world. Our headquarters is located in Italy, where we actually produce 100% of our components internally. We also have a branch in North America. We use this branch for logistic purposes. And then in all the highlighted area in the map, we have all direct people that are present in the market, or we have distributors. And keep in mind that also we are inside the DMQP program organized from DMG, so you can also purchase our components when buying new machines. These are the main sectors where we are focused on. More or less we were born from the molding industry, so we have the majority of all the application there, more or less 70%. but we are expanding more and more on aerospace and general mechanics. But since today is technology days dedicated for the tool making, from now on we will speak only about tool making. So if you have any question about others field, please contact directly FCS so we can actually answer your questions. This is a little bit of product lines. Our product lines start with grip devices, where we usually use these grip devices to manage the first phase. We actually insert the clamping seats that we are going to see later on what are them about. And then from the second phases, we move on the standard braille, which is our core business. Our solution not dedicated only in tube, but we also provide standard zero-point systems that are well known in the market to go toward automation. And of course, our solution not limited to the CNC milling machines, but we have also electrical discharge machining, EDM machines, as wire machines, and also sinker machines, because usually the tool makers maybe use also this kind of machine in their process. And of course, our solution not only speak about CNC machining, but they are applied all around the process for producing the mold. Here is where we actually understand what is FCS system about, because it's a method of work that in order to be applied needs to be applied from technical office. We needed to add in the clamping geometry these clamping seats that are highlighted in green, which is a hole, counterbore, and a fillet. And then once that we have applied these clamping seats in the workpiece, we are able to use our components to be able to clamp the part. Since that we needed to use these clamping seats from technical office, our system are supported also on CAD CAM phases for have a better simulation and to understand how to clamp the part exactly from technical office. In this way, we already know what to do when we have the part in the CNC machine, and we don't lose any time thinking about how to clamp the part. We have standardized all the clamping seats, as you can see here. We don't have only one, but we have a variety of clamping seats that needs to be selected based on the dimension of the workpiece that needs to be produced. In fact, when speaking about small parts, we have to use smaller clamping seats, and we have the minimum clamping seat is M5. And then for bigger parts, we have the clamping seats up to M24. We have also standardized all the steps that we are going to see later on what are the steps, and based also on the clamping seats that we select, we suggest to go with smaller steps so that you have more flexibility on how to use these clamping seats. Based on the clamping seat that we select, we have some components basically that we can use in order to clamp the part, and we're going to see later on basically how to use them. In this slide, we actually understand how to add the clamping seats, because our starting point is the base gauge, as it can be seen here. And this base gauge has to be installed in the machine table of the machine, and it is aligned just the first time. Once that this is aligned, we never touch it again, and it stays there with the machine. Then from the workpiece side, we have seen that we needed to insert the clamping seats, and we need to insert them in a way that they match the holes that we have basically in the base gauge. And as we can actually see, the step that I won't mention before is the distance from the holes in the base gauge. So when machining bigger workpieces, we have bigger steps. When machining smaller workpieces, we have smaller steps to have flexibility on how to add the machines. Once that on the workpiece side we have added this clamping seat, we are able to use our components in order to clamp the part and to do the connection, basically. We have the ring that actually has to be inserted in the clamping seat. We have the rod that actually needs to screw it in the clamping seat. The ring gives the center, so we know that the part is already aligned, and the rod gives the force. The body is the connection between the workpiece and the base gauge. We have seen how everything started from the virtual activities, but now we're going to focus about what happens on real activities. Because, of course, as everybody knows, we have a machine time, which is the total time of availability of the machine. But if we want to analyze even further this machine time, this can be divided in runtime and setup time. The setup time is when we refer that the operator basically is inside the machine, aligning the workpiece to then start the program for machining this workpiece. The runtime is when actually the program is launched in order to machine the workpiece. But if you want even further analyze this runtime, it can be divided in cutting time. And with cutting time, we actually refer when the tool of the machine is in contact with the workpiece and is taking away material from the workpiece. And the no cutting time is when the tool is not in contact with the workpiece, but is doing other operations as tool changing or is moving from one part to another of the workpiece, because maybe we have some obstacles to avoid in order to don't have a collision. But if you want to further analyze this cutting time, it can be divided in productive time, where we actually take away from the machine real conform workpieces, so they are in tolerance and everything. And we have also the non-conform that something wrong happened during the process, so we can basically reject this part because something wrong happened. This is for the standard system. FCS system aim to maximize the productive time, but also the runtime, minimizing all the red areas that we have talked about. Usually this results in a minus 75% of setup time, and we're going to see later on how we are able to achieve this result. And due to this reason, usually we have an increase in plus 30% in higher machine utilization. Now we're going to actually see how we are able to reduce the setup time. So we have seen that in the previous slides how the base gauge is installed in the machine, and this is our starting point. And also we have seen how in order to apply our system, we need to create a reference in the workpiece. So basically, since we created the reference, we are able then to move on the machine. And since that conceptually we have created the references, we skip this alignment because we have the machine table, the base gauge already aligned for the first time in the machine. And then our customer usually asks us to number the rows and the columns with letter and numbers. So to people that have never seen our system, I always explain it's like playing a Lego and Battleship at the same time. Battleship because we have the base gauge that is similar to a battleship field. And we have also letter and numbers. So usually, for example, we start from B2, okay, C4 or D7, and then from these points we start building the castle to actually be able to clamp the part. And with this castle is when I referred to the Lego, because our components are modular and usually is like some Legos block that we can actually use over the position. And the good thing is that everyone in the tool shop can do this setup. There is no need for a CNC well-experienced CNC operator, but even the last arrived in the tool shop can do operation. And we all know how it is difficult to find good CNC operators nowadays. So for this, for sure, is one of our big advantages. But now we're going to focus on how we are able to reduce the cutting time and also the productivity time on next slides. Speaking about the cutting time, we are able to increase it because we increase the material removal rate, and we usually clamp the part by the bottom surface, so we actually leave available all the 5 surfaces to be attached by the tool. And so we increase the accessibility for the workpiece. And also, since that we spoke that usually are complex geometries, these are not easy to be clamped with standard clamping devices. So with our components, we actually have stronger clamping forces that usually increase the clamping forces. And due to this fact, we are able to increase even the tool parameters, the tool feed rates, and also we minimize the vibrations of when working the workpiece. Speaking about the productivity time, since that we actually clamp the part from the bottom surface, we leave basically all the 5 axes, all the 5 surfaces for easy work basically. And so we minimize the risk of collision that this can result in non-conform parts. And also we keep the position and orientation all over the machines, because if we think that we actually have all the system applied in all the machines, then we can move one part from one machine to another with the same references, so we don't have that error that the CNC operator can do an error on alignment on the part. And for this reason, we minimize also the rejected parts, and we increase the quality of our components. Now we're gonna, on next slides, we are gonna go over a case study where I provided the first phase that are clamped with our grip vices. And as it can be shown here, we have a variety of multi-clamping solutions. Usually even in the first phase, but also in second phases can be adapted. For us also, it's not important that we can actually do vertical clamping as well as horizontal clamping in the same way. And as you can see, the important thing for us is to have the starting grid where to apply the components. And of course, if we are speaking about 5 axes, we have seen how we clamp from the bottom surface. We raise up the part, and we are able to even work undercut on the work. So the accessibility of the workpiece, it is increased, and some operations that before were not possible, now they are possible. And this usually brings a lot of efficiency in our workpieces, basically. Speaking about drilling, one of our advantages is that we can do passing through holes that before were not possible unless we want to damage the machine table or the other equipments that we have. But as I said at the beginning, our system is not only to be applied on CNC machines, but it can be applied on EDM sinker machines and also EDM wire machines. And if you want, we can even incline the workpiece to have better accessibilities. This can be done in EDM sinker, but it can be done also in wire EDM, but it can be done even in CNC machining. And of course, our main feature is that we keep the references all around the processes. And of course, this can be used also in measuring machines, because, for example, if you want to have a quality check in order to understand if the part is in tolerance and everything, we can basically move the component from the CNC milling or from the sinker ADM to the CNC to the measuring machine in a way, in a fast way, basically. And of course, we can actually see how all the components are applied in all the different stages of production. And something that we always say is that the clamping solution is only the first step to go toward automation, because in order to be automated, we actually needed to know where it is located, the part on the space of the CNC machine. And with our components, we are able to do so. And so we actually see how using a right clamping system is the first step to go toward automation. Thank you for listening at our presentation. And if you have any question, please contact us directly at FCS or through our distributors. You can find us here later on if you have any question, and feel free to also visit our website where you can contact us and directly ask us some question. Please, if you have any question later on, there are some time for question and answer. And for a moment, I leave the speech to Tabis and to Mr. Kibark. Thank you very much.
Thank you very much, Mr. Bazzo, for your interesting speech about clamping. So you will see him later also for the Q&A here back on stage. So we have talked about the